Good morning. My name is Richard Reister, and I'm the Program Manager for the Light Water Reactor Sustainability Program. And I'll be covering this next topic, which is RC6, titled Performance of Joint Human-Machine Systems. I'll first provide an overview of the Light Water Reactor Sustainability Program, cover our I, and C subject in a little bit more detail, and then address the call specifically. We'll also have the technical point of contact for this call is Bruce Halbert from the Idaho National Laboratory, and he'll be on the call as well to address any technical questions. So first, we have the Light Water Reactor Sustainability Program, which is focused on keeping the existing plants operating as long as their safety and economically viable. And generally, we think of that in terms of beyond the 60-year time frame, which is the end of the first license renewal. So the goals of the program, addressing the scientific basis to understand, predict, and measure changes in materials as they age. Apply this knowledge to develop methods and technologies that support safe and economic long-term operation, and research new technologies that enhance plants' performance, economics, and safety. And so that's the II and C topic is really in that third goal of new technologies. So we divide the Light Water Reactor Sustainability Program into 4 technology pathways. The first is the nuclear aging, materials, and degradation, which is the largest pathway, and it's also what people typically think about aging plants. We want to address the materials issues. So we investigate the scientific basis for understanding and predicting the long-term environmental degradation behavior of materials in nuclear power plants. And we develop means to detect and characterize aging processes. So this is really non-destructive evaluation techniques. And we're looking at ways of mitigation and repair technologies as well. The second area is risk-informed safety margin characterization. And here we're providing tools to industry that will allow them to better understand the impacts of replacement and repair decisions on safety and reliability that will ultimately influence their decisions related to long-term operations. So it's a toolkit for understanding safety margins as plants age. The third pathway and the subject of this call is the advanced instrumentation, information, and control technologies. And here we're addressing the long-term aging and obsolescence of the existing instrumentation and control technologies and development of new test technologies. So we're working with industry to establish a strategy to implement long-term modernization of I&C systems, and develop another element is developing advanced condition monitoring technologies for reliable plant operation. And I'll cover this in a little bit more detail. Later, the fourth pathway is kind of a catch-all for emerging issues, and here there's a couple of areas we're currently addressing. One is the environmental concerns, which are potentially requiring backfit of cooling towers at plants, which is an economic impact to the existing plants, and we're also addressing the lessons learned from the Fukushima accident. So in the one pathway, the Advanced Instrumentation Information Control Systems pathway, again, we're addressing the long-term aging and reliability concerns of the existing I&C systems and developing new test technologies. Working with industry to establish a strategy for modernization of these technologies, and this really mostly affects the economics of the plant, through performance and the number of people it requires to maintain these aging systems. And we need to develop the scientific and technical basis to support the safe and efficient plant modernization. And this third goal is kind of more closely addresses the topic of the call. As part of this modernization, there's the modernization of the control room, and some people have thought we could just replace the control room with a digital system, but that's not really that practical, especially talking to the existing plants. They just don't think that they'll ever be able to wholesale replace their control room with a digital system like you would see in a modern plant, a modern new construction plant. So we really end up in a hybrid control room situation. So what we're interested in developing the technical basis and standardized methods to support a stepwise modernization of these aging INC and strategies for the refurbishment and replacement. So this is the work scope, not so much the call, but the INC pathway. And that's the human factors engineering plan for an optimized human factors control room layout with integrated digital operator interface screens and analog controls and indicators. So it's a hybrid control room layout with both digital and analog systems. And this is a pilot plant we have with Duke Energy, which is ongoing. So the call is related to the performance of the joint human-machine systems. So research is desired related to the development of methods and measures that can be used to evaluate the performance of the joint human-machine systems in nuclear power plant main control rooms. This research will be used at interim stages of the main control room refurbishment and will be used to evaluate the quality of resulting designs in terms of joint human-machine system performance. So the key is to understand how these hybrid control rooms are functioning with human interaction and to ensure that we're not degrading the overall performance but actually enhancing performance. So how do you measure that? How do you ensure that the performance is being improved? So we should be capable of verifying that the design features have achieved their objectives, as well as to validate the resulting designs of the integrated system. So the research should account for techniques and be sensitive to changes in human system interfaces and automation that may change the role of operators in a way that interact with the plant system. So, again, as you make these changes in the control room, the interaction of the operators with the control systems will be changing. And so how can that be measured? So the emphasis of this research should be on qualitative and quantitative approaches that can be used to measure the quality and other dimensions of the human system performance with the advanced digital INC technologies as well as with the existing analog systems. So again, it's the mixture of the both that's of key concern in this area. That's it. Sorry. Bruce, if you're on the line, do you have anything you want to add to that description?
Okay, I'm here, Rich.
Did you have anything you wanted to add?
No, nothing I wanted to add. I think the call sort of speaks for itself. Be happy to answer any questions that people have.
So the focus on hybrid control room is on hybrid control rooms and not new digital control rooms.
Yes, that's correct. So there's already a lot of analysis done related to fully digital control rooms that are done by the vendors that are have implemented these control rooms for the new plants. So we're really interested in the hybrid digital and analog mixture control room.
Does this call assume collaboration with Duke Energy? And if so, does it assume part funding from Duke?
It does, not sure about assume, but it anticipates that the awardee would participate in the pilot plant project with Duke Energy. I would not anticipate any funding from Duke Energy to the awardee. The awardee would get their funding through the NEUP award. I'm not sure that I know enough to say that I can exclude that possibility, but that's what we're planning on is the funding for the awardee would be through the NEUP program and not through some type of other joint arrangement with Duke Energy.
The final question, will thermal and irradiated welds or casts in materials aging be considered?
Say that again. It doesn't seem to relate to this call.
The question is, will thermal and irradiation in welds or casts in materials aging be considered?
Not in this call.
I think that question relates to some other topic.
Is experimental validation essential?
Experimental validation.
Rich, can you hear me?
Yeah, I can hear you.
Yeah, the intent of developing these methods and measures for measuring performance of the joint human-machine system is for experimental validation. The experimental validation can come as a part of the pilot projects that we're carrying out, and they don't necessarily have to be conducted separately, but there needs to be a technical basis of some sort established for each of the performance measures and methods that are proposed for measuring joint human-machine system performance.
I should probably add, Bruce, that I remember I didn't talk about it much, but a lot of the research planned for these hybrid control rooms is anticipated to take place at Idaho in the Human System Simulation Laboratory, which is a flat panel representation of a control room, and it can simulate.
That's a good point, Rich. On your second slide, I believe that there were some pictures showing operators from Duke Energy participating in some system studies in the HSSL. So if experimental validation is needed, there are some reference facilities that can be made available, including simulators and perhaps even plant personnel to support some of that validation. And some of that validation will come as a part of the pilot projects themselves.
Where are these facilities that are spoken of in the pictures?
The facilities in the pictures are at the Idaho National Laboratory, but there may be other locations available as well. But principally for the purposes of this research, these facilities shown in these pictures are at the INL. They are available to support the research that will be conducted through the successful NEUP award.
And it's anticipated, I think, Bruce, you can confirm this, but since we have a pilot plant project with Duke Energy, they'll be providing plant operators that'll work in the Human System Simulation Laboratory at Idaho, doing the research related to some of these proposed hybrid analog and digital systems.
Yeah, that's true. In fact, the successful awardee of the NEUP will be part of a broader project team and will be proposing methods and measures to be used as part of these integrated system studies and validations, and so they will have access to participate in the control room modernization activities with actual plant operators, plant staff at Idaho, as well as perhaps at the host facility, depending upon the availability to do that.
Will experimental results in V&V and the training simulate? Will experimental results in V&V in the training simulator be acceptable instead of the MCR?
Yes,